now live on Facebook. It is December 18th, 2020. And today I am joined for a live podcast recording of Tales from the Heart with Dr. Euan Ashley, who is an old friend and a wonderful colleague at the Stanford HCM program. Welcome to our Facebook page and the podcast, Dr. Ashley.
Well, thanks for having me, Lisa. It's wonderful to see you today.
It's great for you to be here because we have something kind of different and exciting to talk about, because not only are you being a doctor every day doing the work that you do, but you wrote a book, and I am lucky enough to have an advanced copy of it right here with little markers in there and everything from all the interesting parts that I've already found. So how does it feel to be now author, I guess again, but an author of a book that's about to be published?
Oh, it feels kind of nerve-wracking and a little weird. I still don't really believe it, honestly. I find it hard to call myself an author yet. And this is, obviously in our day job, I write a lot of scientific papers, but this is a whole different thing. This is a book aimed at regular people. I aim to try and tell some of the stories of patients that I've known over the years, and I just live in awe of the experiences, that our patients go through, and I just felt I wanted to try and tell some of those stories, and also of the scientists that we spend time, those who spend the early hours and the late hours really working to try to find new therapies, find new diagnostics. And there's just, I thought, some incredible stories in there. So it started like that, and this is where we're at. I guess there's a book. I guess it's coming out, but I still don't believe it. Yeah.
It showed up in my mailbox, so it's a real book now. Yeah. So let's go backwards before we go forwards. I want to give everybody a little bit of context on our relationship and how long we've been working together and how this started. So one day at the HCMA office, I get this phone call from this guy with a funny accent who tells me that somebody in England named Bill McKenna suggested that he reach out to me to talk about HCM practices in America. And this is like 2006-07. Centers of excellence are still a very new concept, and there was only maybe 6 or 7 programs developed in the United States, and in comes this guy with this strange accent saying, I want to do it out in California. And that was a long time ago. And since then, the HCM clinic at Stanford, now, I don't know what your actual numbers are today. You have 1,500, 2,000 patients?
Yeah, that's right. Yeah, about that.
Somewhere in that neighborhood.
Yeah.
And you've been providing excellent care for, going on 2 decades there. I know
we can't be that old, can we? Yeah, I think maybe,
I know.
maybe 2
Somehow
decades.
that happened. We were the young ones back then. And
Right.
Things change. So we move forward. The program has grown. You've got some great colleagues on your team there. Shout out to all of them. I could go through the whole list, but of course, Heidi, who I've known for almost the whole time as well with you, and your fantastic genetics team, and so many newer faces over the years. Right. It's grown to something pretty amazing, which gives you an opportunity to see some pretty amazing case stories about HCM.
Yeah, it's been incredible over the years. And at the beginning, of course, we all start out not knowing anything. I read papers. I trained with one of the heart failure doctors at Stanford who saw a lot of hypertrophic cardiomyopathy patients. And I knew that I was really interested in the disease and really interested in the overlap and thinking about athletes with their heart problems and thinking about distinguishing them. And I knew I'd read a lot of papers from one Barry Marin and one Bill McKenna. And so I sought them both out by email. I was actually in London, and Bill was nice enough to take a quick meeting and download a little bit. And I just sat there also in awe of his career and the things that he'd done. And he gave me a few pointers, obviously said I should go meet Barry too. And then your name was the next one up. And so you were kind enough to take my call and really helped, as you have so many other centers and so many other doctors who are interested in really giving good care to HCM patients, to get them started and realize what they need to do. You'll also remember Paul Wong, our EP.
Yes. Yeah.
Chief of EP was a major force in really setting this up. In fact, he put together the first business plan even before I joined the faculty, which was nice of him. And that's where, in response to that's where I met Heidi, who I knew from the CCU at Stanford. And I remember meeting her for lunch and saying, hey, there's this clinic and you're interested in spending some time. I know we don't really know each other, but it could be an adventure. And she was kind enough to jump into the adventure. And that's how it all began.
When people think of, well, how does an HCM program become an HCM program? It may seem like it's a very logical stepping stone, but it's kind of a leap of faith in the beginning to say, I know these patients are here. I really want to spend my time in my career working with them. How do we organize them? And getting a major medical institution to make that commitment is a big deal. And back then, now I'm getting calls all the time. We want to do it. We want to do it. We want to do it. I'm like, okay, slow the roll. It's not, you don't just turn on a light switch and it happens.
Right.
It takes time.
Yeah.
It's a lot of experience. So let's go back to the book here a little bit. You have this amazing cross section in your brain, as far as I'm concerned, cardiology and genetics. Not everybody thinks both at the same time, but I'd be curious to see how you dream, because I think it's going to be fascinating. So you write a book about the Genomic Odyssey, and the subtitle is Medical Mysteries and the Incredible Quest to Solve Them. And HCM really fits in perfectly to that title. And what has happened over the years with HCM, and you give a fabulous historic recording of where HCM actually came from, going back a lot further than most people do, going back into the 1600s and figuring out some old literature there. But then you talk about the modern history, I'll call it, and the Morrow-Brunwald story. Are you as fascinated with that story as I am?
Oh yeah, I mean, I think that one of the joys of the book, really, I just loved this, was going back and finding these old stories from ancient history, first of all, and you know, digging back through very, very old texts, even some of the original texts from the 1700s and 1800s, when we first realized that there was a disease where the heart was thickened and it seemed to be associated with sudden death. And then in the same chapter in the book that I talk about the history of HCM, we talk about the history of sudden death and the history of bringing people back using electricity, which is also fascinating. And then, as you say, the more recent history is the one we're a bit more familiar with, but even within that, there are these amazing interpersonal stories, and the stories with Morrow and Brunwald were just unbelievable. I mean, the fact that these two were friends and were really pioneers in working together to define what hypertrophic cardiomyopathy was at the very beginning. The story where first of all, Brunwald had found a patient that he thought had an aortic valve problem, and was looking for Morrow to do an aortic valve surgery, and then he got called by the senior surgeon into the operating room to account for the fact that the aortic valve was normal. I just love that idea. That's a giant like Brunwald, who of course now is as famous a cardiologist and as influential a mentor as there is, would be called as a junior cardiologist in by the senior surgeon to demand where the aortic valve problem is, and then them finding out together that the measuring the pressures inside the heart really laid out what obstruction was, and then the whole odyssey that came after that in our understanding, not least the fact that Brunwald later diagnosed Morrow with hypertrophic cardiomyopathy. I mean, that's an unbelievable aspect of the story. As Brunwald himself said when I interviewed him for the book, you just, if someone had pitched this as a TV show, you'd say, oh, that's too ridiculous. That would never happen. But that's exactly what happened.
We share that experience. I went to Brunwald's office years ago and sat in a big brown leather back chair and listened to this man tell stories. I could have stayed there all day long. It was amazing. But the cutest part of his story to me was when he said, after he left the OR and he was really upset, he called his mom.
He didn't tell me that.
Yeah. And his mom was mad that, how dare he talk like that to my son? You're wonderful. I'm like, oh my God, I would love to have met your mother. So just a fascinating story. And you captured it so well in the book. And I do hope that I'm teasing people enough to want to go out and order the book. It's available for pre-order right now, not available to the public until February, but you can get that in the link above. So now we get to chapter 15. I'm going to just go right up to chapter 15. And we have a special guest to join us to talk about this chapter because she is featured in the book. Her name is Leilani Graham. And we're going to bring her on screen right now to join us.
Wonderful.
And she's probably going to be sideways when she comes in, and she's going to turn it really fast. Good morning, Lilani. Thanks for joining us.
Good morning.
There you are, your normal posturing again. So we've just got to chapter 15. So Euan, why don't you lead the conversation here about how you come to know this lovely young lady sitting with us today?
Well, when I was thinking about the book, and obviously knew I was going to talk a lot about hypertrophic cardiomyopathy, there wasn't really any question. It took about a microsecond to decide whose story I would, whose story I would focus on if she was kind enough to allow me to do that. And so not only was she kind enough to allow me to do that, she spent many hours going back over our whole history together, and much of it even before we knew her, with Heidi, we talked about, and myself. But the idea was to try and intersperse the history of HCM and the history of our use of electricity to bring people's hearts back from bad rhythms in with the story of a real person, because that's what brings it alive, and that's why we all do this. And so, yeah, like I said, 2 bit per microsecond, and Lilani was kind enough to agree. And so, yeah, in the book we tell her story in as best I can, her own words. And also talk to her mom and dad as well. We've known each other for many years, but yeah, I'm one of them. I mean, I want, we should hear from her, but I remember our first meeting. Let me just say that because she was transitioning from pediatrics, and so Heidi and I would go over to the Children's Hospital, which is right next door at Stanford, to try and ease the transition from the nice hospital with the fish on the ceiling, as Lilani put it, to the constant beige of the adult hospital. So we would go over and try and make that transition a little easier, and that's where we met, and we're just astounded by the poise and grace of this very young, I guess 16-year-old at the time, and her questions from driven by her own research and from her biology classes, not just about the disease but about genetics and the testing we might do and what we do in the adult side. So that was very memorable first meeting. And it was just the start of a long history together.
So Lilani, you want to tell our viewers a little bit about your story? They're going to get the whole story when they get the book. So let's just give them a taste of why would you be the one featured in this particular book?
Well, first I want to say I remember that meeting too. And I think I was quite lucky to be in the advanced bio class at the time, because it made me sound a lot more knowledgeable about genetics than I probably am today. But yeah, my story started when I was 13. I had been running on a treadmill in our garage, and my mom was supposed to be at a meeting that night. She happened to stay home, and she heard me just kind of moaning on the ground. Went in to check, and it was like full-blown seizure / unresponsive. Nobody understood what was going on. Was taken all the way to the ER in the Children's Hospital, and they took a while to kind of figure it out. They're like, did she take something? Did she bang her head? What's up? And the second they did an echocardiogram, it was very obvious that I had HCM. So I had a defibrillator put in, I think 3 days later, and then kind of, lucky when I was 13, just bounced back, went back to school, then ended up having my second cardiac arrest only a couple months later. And that was kind of when we figured out, okay, so this is much more of a severe case than we had initially thought. That's going to mean a total life shift. And that's kind of, it totally defined my life from then on. Didn't do any sports, but, got some free time during school. So that was nice. Ended up diverting into theater because that was my other passion, and then went to college for it. And then ended up having, well, I'll leave the rest of the book, but more arrests. And then eventually went downhill and ended up getting a transplant, ironically on the same date as Lisa, but 1 year before.
I realized we were two days.
Yeah, I didn't realize you were transplant twins here. Wow.
Oh my God, I just got chills. I brought her with me, by the way, seeing as that's mentioned in the book too.
Lovely.
This is really, that's really important.
Oh my God, two buddies. That's awesome. So you're coming up to 5.
Yeah. Mm-hmm.
And I was actually at Stanford for a meeting when you were recovering from your transplant.
Oh, get out. That's too funny.
Yeah, you were having those first couple rough days, and we were there for a conference. Yeah. And I was hoping that we would get a chance to see you, and I was going to try to go over to the hospital to visit you, but you were still in ICU, and I figured I'd check with you later. And then we ran into each other in San Diego last year.
That's right. That's right.
And we're like, wow, we both made it to this point. So
I was actually in the hospital again on your transplant date because I was having more complications. So, we're just twinning all the time.
It's this HCM twinning thing. I have a couple of you HCM twins for different reasons. It's amazing how tight the community really is and how much we have in common. So on top of, your cardiac arrest, what about the genomic aspect of your story? Were you able to identify the causative gene?
Yeah. So, initially we had no family history of it. It was quite a surprise to my parents when they were told, oh yeah, this is an extremely deadly disease. You're lucky that your daughter's still here. But as soon as we met Dr. Ashley and Heidi, we ended up, I think, being one of the first families, Euan, you can correct me if I'm wrong on that, to be genetically tested for HCM at Stanford. And we ended up finding something we weren't expecting, which is 2 variants, both on the same gene, one from mom, one from dad. And so that started not only my sort of foray into being a lifetime heart patient, but my parents as well. And fortunately, my younger sister has neither of the genes, so she's set. But it did end up really defining, our participation in science and medicine.
Pretty cool. So we thank you for sharing your story today. I'm going to go wrap up with you, and we're going to do some Q&A. Lilani, thank you so much for sharing your story and participating and allowing Dr. Ashley to share your story in the book, because I think you're going to educate a lot of people. And I think you're going to inspire a lot of people as well, because you've always inspired me.
Well, thank you. It was my pleasure and my honor to be in the book as well. It's quite fun.
Great. Okay, I'm going to pop you out of the room now.
All right. Bye, guys.
Thanks. Okay. So she's just such a lovely girl.
Isn't she awesome? I mean, it's just unbelievable.
She
is so inspiring. And her story, I was recording, as we were talking earlier, I was recording the audio for the book next week. And that's a whole story by itself, but I was allowed to be the narrator for the book. And so the audio book is actually me. And it was really emotional, honestly. I mean, I was in a booth just by myself, but reading these words out loud, but telling the stories of patients I've known so well, and thinking about what they've been through. I mean, your own story is in the book too, just in brief form. I know you're writing your own book. I can't wait to read that. But you were kind enough to let me share some of your story there too. And of course, the amazing work you've done for the HCM organization over the years, which has been so supportive to so many of our patients, and Lilani, of course, being one. But yeah, incredible.
So I remember going back to, I think, an HCMA meeting probably around 2010-ish. I think I gave you the talk of the $1,000 genome. Is it possible? So I'm feeling kind of old, because these are dreams that you have for your whole life, and you wonder if you're ever going to get there. And in a decade, we're kind of almost there, aren't we?
We're there, yeah. We're even beyond there, actually. Now, I think probably $500 is probably a reasonable number to use. Yeah, and we have a pretty clear route down to $100, actually.
And we're using genetics for entertainment in some way, or ancestry and hereditary risks. We have a program right now, I don't know if you know this or not, through 23andMe has donated some kits to Myocardia, who gifted them to the HCMA, and any member of the HCMA can have one of these kits for free. They just have to go order them. So, we're using genetics for fun and for information.
It impacts so many parts of our life. And again, as we discussed near the beginning of the book, part of the odyssey of the genome here is just where we've come. I mean, that first genome was basically $3 billion for the Human Genome Project. It was 10 countries. It was 10 years to produce one genome. In fact, it's just half a genome, because it's just one line of letters. And to think that just over the course of basically 10 to 15 years, we were down at the point where it's $500. This is something, compared to most medical costs, this is pretty small. And so when we think about what that ability has brought to patients like Lilani and other patients with HCM, the ability to understand what is actually causing their condition, and then map it through the family so that we can really focus on the individuals in the family who are most going to need it, and make sure they get the care that they need for screening, while other members of the family can realize that they're not at any higher risk than the general population because they don't have that gene. That's a really powerful thing, and it's just been amazing to be part of that journey as the whole community moves forward in understanding what to do with this data.
I was early on in the process personally. We participated in a trial research, basically, not a trial, research, and we were able to identify the genetic mutation in our family back in like 2001, early 2002. So I knew my daughter's status when she was very young, and we really didn't even have a good understanding of what that meant, other than she needs to be followed. I admit I wish that it was a negative and I didn't have to worry about it, but at least I knew. and it gave me some power to make decisions with and help her focus her life in a direction that was the best for her. But it's an evolving place. What do we do now? We know we can use it for family screening. Is there a time in the future where we're going to be able to use this genetic information for more? What do you think?
Well, I think so, and I think as you know, I'm a nerd. I'm a total nerd. I love computers and data, and I've always been that way. Even before I really did any medicine, I was programming computers, and so I think that I've always thought about the genome and variations that we find in the genome along a spectrum, and that's the easiest way to think of it. For HCM and other diseases like that, we sometimes call them Mendelian. But that's generally speaking, one variant is really the variant to rule them all. It's one we trace through a family, and it basically causes most of the disease. But in other areas, you talked about 23andMe a few moments ago, for conditions like high blood pressure or coronary artery disease or diabetes, we think of those less as one gene variant that causes the whole disease, but rather thousands, maybe even millions of variants spread across the genome. And of course, I've always been interested in both those, but generally the people who do each of those have been in different camps. They've been trained in different ways. They work in what's really amazing now, with the genome being so accessible, is you can get all of that from one genome. And actually, early next year, for our HCM patients, we're introducing something called a genome panel, where we run a genome as the backbone. So for every patient who comes from an HCM panel, they're going to get in the background a whole genome run. But what we'll focus on, of course, will be the key HCM genes, and that'll be the report as standard. But if we don't find anything, which is still the case, as you know, for a significant percentage of people, what we have on file now is their whole genome. So as we learn more, as we get more genes, we can just go back and look it up. We don't need a new test. So I'm really excited to bring that technology literally to the bedside of our patients starting next year.
That's amazing. So that kind of answers my next question. Where are we going? We're going to use more data to better,
I think so,
identify patient populations.
Yeah, I think so. And we have the tools now. The computers are so much better than they used to be. There's still a manual component. There's always the last mile that has to be a real person looking at the data and looking at the evidence, and then bringing it back, of course, to the patient. But I think we'll be able to lean not just on the panels that we've done to date, where we look at just a small number of genes, but we'll be able to look across the whole genome, and potentially even start to mix these two camps, if you like, where we can look for the single gene that maybe causes the disease, but then also the rest of the genes in the genome that can also modify the effect of that gene. And I think we'll be able to do all of that together in the future, and help really much more than we have to date, even in the sort of preventive aspect of genomics.
So define that a little bit more. What is the preventive aspect of genomics?
Yeah, well, so if you're thinking about things like coronary artery disease and diabetes, those kind of where we think of lifestyle as playing a big role, and it does, at least half the variation between people is things like diet and exercise, all those things that are really important. The other half for those kinds of diseases is also stored in our genome, but it's really spread across most of the genome. And so being able to quantify that better, for example, if you go in right now, worried about heart attack risk, your doctor will ask about smoking and diabetes and all that, cholesterol. But they won't generally ask much about family history to date, maybe a little, and it won't be very well quantified. And starting from next year and moving forward, we're going to start to be able to quantify that family history as well for those kinds of diseases. So that's part of the preventive genomics. And maybe even finally, this idea we talked about a long time ago, pharmacogenomics, the idea of using your genome to choose better medicines, ones that really suit and are really personalized towards an individual, and try and avoid side effects, because we all know that many of even the great drugs that we have all have their own side effects that we'd like to avoid.
I think that's going to be incredibly helpful and stop the journey of patients who get lost so often in meds that make them feel worse than the disease itself and don't provide a great deal of benefit, but they feel like they have to take them. So if we could better target which meds for which person, and I think in a certain context, that's kind of chapter 18, precision medicine, and how do we use this knowledge to better treat ourselves? So it's really, I think we're going into some very interesting. I'm trying to get my Facebook page up here. So I think it's really interesting how we're moving towards that. I was on an advisory panel, like it's got to be 10 years ago, and I was asked to be on, and I said, okay, I'll come and I'll give you my input. And this was very, very early. How do we use genomic information to prescribe medicines? I'm like, well, first you have to do the science to figure out which medicines are attached to which genetic modifiers or information. And first you need to do that, and you're not there yet. And they were ready to deploy based on like one drug, capitopril, and warfarin. I'm like, I don't think that's enough to launch an entire concept off of, but we're getting there.
Yeah, it's one step. I say in the book, you can't do two until you've done one, which is a really obvious thing to say. But on the other hand, it just means, baby steps first, and crawl, walk, run is the answer. We often feel, those of us who love technology, I think, often spend so much time trying to get to the one. And then, of course, other people can often take it and really scale it, which is a very exciting part of pushing technology boundaries wherever you can.
And I think we all need to push those boundaries harder, more consistently, maybe not faster, but consistency. I thought about something else as I was preparing for talking to you today. And this is going to date us as well, because there was a conference we went to. I forget exactly where it was. It wasn't on campus. It was off campus. And Cambridge was there talking about this new SICD concept, but it wasn't called an SICD yet.
Right.
And we both went, okay, this is really cool. This is going someplace, but it needs a little more zhuzh behind it, and some more data and some tweaking of technology. And then Boston Scientific bought the technology, and now SICDs are commonplace, which again made me feel pretty old to watch the development of an entirely new concept in defibrillation. So, we're growing together, and, your book, looking back at some of these conversations we've had over a while, and to see where we are today, it's kind of amazing how fast things have moved.
Yeah, it's amazing. And I think that, again, a bit like the history of HCM, I mean, there was a very old history of it, like they used to call it galvanization, where they would bring people back from the dead in the 1700s, when they first made these Leyden jars, that you could, like a battery. Benjamin Franklin used to talk about them. And people would have sewn in on their shirts, I don't want to be galvanized, a bit like people now have a do not resuscitate kind of order. But it didn't really, for 200 years after that, really become something that was in mainstream medicine. It's actually been pretty rapid over the miniaturization, of course, of technology, and then eventually being able to implant. And then now, as you say, with the subcutaneous ones, we're not even needing to use the vasculature anymore. We can literally put these devices under the skin. So we've come a long way. And again, just the amazing stories of the patients who helped us get there. Some, in one case, many of these were tested on dogs, like the first defibrillators. Tell that story in the book, the first one.
Well, and I think one of my other favorite innovators, because some people idolize rock stars. To me, Eugene Brunwald is a rock star. Murawski is a rock star. And you tell Murawski's story in here as well, who's just an absolutely fascinating human being. I've met members of his family. Unfortunately, I didn't get a chance to meet him. I used to go to the Murawski dinner it was AHA used to run that one, or ACC, I forget which one. But I met his daughters there, and just an amazing family, amazing contributor to science. And for those who don't know who Michel Murawski is, go look him up. He's just, if you have a defibrillator, or anybody you know has been saved by a defibrillator, thank him. Because without his tenacity, I don't think it would have happened, because it shouldn't have worked, and it did.
Yeah. And the story way back from when he left his family, age 15, and then went off and trained in medicine, and then came to the US at Johns Hopkins. Just his whole life story was unbelievable, with the story with his mentor and that single-minded determination.
5 movies in this book. I mean, you get any one of these small stories could be just an epic adventure story. And I just think you did such a great job at giving them a synopsis, but depth, and telling the stories really well. So I hope the book is really successful. I hope more people take the time to think about the role of genomics in their life, what it could mean for them, where the science started, where it's going. And may I say, I hope that we return to a country that is very focused on science and innovation, and really using these amazing tools that we have for the good of humanity. I'm not getting too lofty there.
Well said. I couldn't agree more.
Okay, if there's anybody who has any questions, please post them now on Facebook. We're happy to address them. Gretchen just gives a shout out that she's watched all your YouTube videos when she was diagnosed, and it really helped her understand HCM better. And that's probably one of the most referenced videos that I've ever taken part in. I think it was the first time I came out to Stanford. Remember my luggage got lost and I was wearing a red
I remember
sweater.
that. I remember that.
That video of that patient meeting that night was one of the first that was put on YouTube. It was a relatively new platform. To this day, people will say, I saw an interview with you. It was a while ago. And I think you were at Stanford. I'm like, was I wearing a red sweater? And they're like, yes. I'm like, oh my God, I didn't even have my makeup that day.
Yeah.
I was not happy. I'm like, oh, we're recording this. Awesome. Yeah. But it's helped so many people. And, that theory is moving forward today. We've developed online support groups, which are launching this month through the HCMA. And already this week, we've had these interactions with individuals who never saw anybody else with HCM. So those videos and these outreaches and making people real and doctors real and advocates real and bringing us all together and seeing how hard we've worked. It's awesome.
It's such important work, and it's just incredible the way, Lisa, you've done this over the years. I don't want to embarrass you here, but I think it just, these things don't happen by chance, and the fact that you've dedicated yourself to this and to the good of all the patients, and also never been scared to stand up to the doctors and tell them what they need to do, which is really important.
It does get interesting from time to time, but when you're respectful and you've got a point to make and everybody can stop and listen for a second, I think we've developed something that I hope other disease states can mimic or build upon, because we developed this relationship. I miss the in-person meetings in New Jersey. I want to bring those back, because getting everybody under one roof for 2 days, physicians, patients, commingling, the bar time was always the best time.
Right.
Gotta love
Social
that.
time. I remember those days.
Yeah, they were
they seemed kind of far away. Yeah,
they
but I remember.
But we had great conversation, and we take away the veil between the two and understand that we're all human beings. We're all trying to live a good life, and we're trying to help others do the same. And we can do it together. We can be a partner. I see things from a point of view that you don't see. You definitely see things from a point of view that I don't see, because your brain is like ridiculously busy all the time with technical stuff that I'm really appreciative for you for doing. So this is the book. The link is above or below. I don't know which way I'm pointing, but the link is here. I encourage you all to get a copy, read it, get an urgent or early one. Oh, so we do have a couple questions coming in. What is best for genetic testing right now? Is there a difference between saliva testing and blood testing?
I think saliva has been very helpful, especially for family member testing, because obviously it means you don't need to go anywhere. You can make the saliva in your home, put it in the tube, put it in the envelope, and send it off. The only real difference at the technical side is there's a bunch of bacteria in your saliva that aren't in your blood, but that's pretty easy because we just don't use the bacterial DNA when it comes out the other side. So really, as long as you get enough saliva and you fill it to the line, saliva is excellent. So no issues using that at all.
So you're not losing any diagnostic possibility if you do a spit test versus a blood test.
No, definitely not. Just very rarely. I was going to say just incredibly rarely. This is not something anyone needs to really worry about, but the cells from your saliva are a little different from the cells in your blood, and so there's a little bit, on the very cutting edge. There's every now and again patients who have more than one genome. I have a chapter in the book about that, with a patient with long QT syndrome, who we end up finding out has more than one genome. Is a little baby. In her case, actually, her genome was the same in saliva and blood, but in different parts of her body, she actually had a slightly different genome. But that's a very rare situation. For most of, well, something called mosaicism. It's actually, for once, a nice and quite useful word. If you think of a mosaic, it is a beautiful picture with lots of little tiles and lots of little stones. But if a mutation arises, and it's very rare, but it can happen, if a mutation arises early on in development, and I mean when you're like 16 cells or 32 cells, then what you end up with is, say, 31 cells with your regular genome, that's you, and one cell that has this one mutation. And this little baby that I talk about in one of the chapters, that's what happened. And the mutation actually happened in a gene for long QT. So then as she grew up from 32 cells to a whole person, some parts of her body, including many cells in her heart, had one genome, and the rest of her had another one. And so that she was called a mosaic. So very unusual. And one of the things we did to try and sort that out at the beginning was take a sample from saliva and blood. As it turned out, both of those were the same in her case, but other cells were not. And in the end, the way we worked it out was flowing her blood cells one at a time down a channel and sorting them into little wells. So literally one cell in each well. And we did a genetic test on every single cell. And what we found was that 8% had one genome and 92% had a different genome. Mind-blowing stuff. So
that is absolutely fascinating. So we have another question here that we've come up with a number of times. Early on, I think we all went, that can't happen, but no, it can. Can you speak to genetic tests in families with HCM, but they might show up with a gene that has been diagnosed as related to dilated cardiomyopathy, and how a dilated and a hypertrophic, which are opposite ends of a spectrum for those who don't know cardiology so well, how are they the same gene?
Yeah, so I think this is one of the most fundamental shifts that is happening. So as you mentioned earlier, we talk about the history of the disease, and I think we define diseases according to whatever the best technology is we have at the time. So there was a while when an ECG, electrocardiogram, was the only test that we had. So that's how we would define disease, or listening with our ears with a stethoscope. Of course, the big change for a hypertrophic cardiomyopathy was when echo came along and ultrasounds of the heart were able to show us hearts that were either dilated, large, and generally with thin walls, or large in the sense that their walls were thick and the cavities were smaller, and that's where we get hypertrophic and dilated. Of course, we're now moving to an era where we start to define these conditions according to the underlying genetics. And so we understand now that even within what we call hypertrophic cardiomyopathy, there are different subgroups of the disease that eventually one day we might treat in a different way. We don't right now. And so that's kind of what underlies this question, that the molecular motor of the heart, where we look for the genetic variants that cause hypertrophic cardiomyopathy, which we think of a bit like a rowing boat. Words like myosin and actin, those are the proteins, but we think of the molecular motor of the heart like a bunch of oars in a water pooling. And those genes that make those proteins for the boat and for the oars, well, it turns out if you mutate them, they can cause either a thick heart or a thin and dilated heart. So it depends a little bit exactly what happens with the specific genetic variant. So there is some overlap. It is possible for the same genes in different people to cause either a dilated version of cardiomyopathy or a hypertrophic version. And we're working really hard to try to work out what tilts the balance. In general, there's some difference downstream. Maybe it's a different part of the molecule, or some other variants within the genome that we haven't yet well defined that tilt the balance one way or another. There's a lot of interest in calcium, for example, in the heart, and how it tilts the balance one way or the other. But the key is that variants in the molecular motor of the heart cause both. And it's not too surprising that a challenge with the heart muscle as a pump would come from a challenge with the motor, and that it could sort of fail in two different directions.
So genes that cause hypertrophic cardiomyopathy can cause dilated cardiomyopathy and vice versa, because it's a regulation issue and a power issue more than anything else that most people would generally understand outside of the geekdom that is you.
Yeah, exactly.
Your peer.
Very well put. Very well put.
To geekdom to me is a good thing. So I don't have any other questions yet. I'll give them another 1 minute, but I'm going to pivot you to another conversation, well, another topic that's a cross between chronic disease, genetics, and living in COVID times, the vaccine.
Yeah.
So while it's not necessarily a topic of the book, it's a new kind of vaccine. And it's scary to some people because they don't understand it. Can you demystify this a little bit?
Yeah, absolutely. And I was just finishing the book as the pandemic was really taking accelerating forward. And so I did include in the end a bit, how could you not, about how genomics, the role genomics played and is playing in the pandemic. And I say is playing quite literally today at Stanford, where we're giving the first healthcare workers vaccinations. And so to have moved from basically in January of this year, first time that the genome was released, it was late January, from the Chinese Ministry of Health, the genome of the virus. So this is RNA, that's the message. We think of DNA as what we normally do testing on. That's what's in every cell, almost every cell in our body. RNA is then the message, and you translate that message into a protein, and the protein is what does the work. So these vaccines that have come from Moderna and from a company called BioNTech in Germany, but working with Pfizer, they're called mRNA vaccines, and the M stands for messenger. And basically, it's an amazing technology that came just as we needed it at the right time, because your patients and the folks in the association will have heard that it took the fastest we ever did a vaccine before was 4 years, and that really was true. And people worry that maybe we cut corners. We really didn't. This is new technology, and also just a singular focus on not wasting any time or money and just moving everything fast. So here in a normal vaccine, what would happen is you take the virus, you'd literally grow up the virus live, and then you kill it. You know, maybe it's heat, maybe it's something called formaldehyde that'll stop it reproducing in the body. So it's now a dead virus, but all the pieces of the virus are still there. And then you would inject that. So commonly vaccines, that's how they work. And that's obviously not very efficient, and it takes a long time, and you need to use chicken eggs to grow it up. It's just not the most efficient way of doing this, especially with a new vaccine that takes a long time. So what if instead you could use the genome, like literally use the code of the virus, which we had in January? You never have the virus. These companies never had the virus on site. They made these vaccines from the code. It was literally an email. I hear it was even Microsoft Word that they sent the design file for these vaccines in. Yes.
Wow.
And then, yeah, incredible. And so then they made basically the messenger RNA, and they stick it inside a lipid particle, so a little fat globule of the messenger RNA, and you inject it into the body like normal. And what your body then does is it takes that messenger and it says, oh, I know what to do with that. I need to make a protein. So your body then starts to become the vaccine factory, and it makes the virus protein. Now it's not making a virus; it can't do that. So you're safe, but it's making a really important virus protein, the one the virus uses to get into your cells. And then your body looks at that and goes, I know you made it, but that looks foreign to me. And so it starts the immune reaction that then is the protective feature of every vaccine. So they're really kind of a magical new technology, but it's based on very, very solid science that has been decades in the making. And what it's allowed us to do is generate these vaccines so quickly. And these vaccines are what's going to save us here. I mean, we do need to keep masking and distancing and all the things we've been doing. We'll need to do that through most of next year. But starting March, April, as more and more people get vaccinated, we're really going to start to get back to normal. And I think we're all ready for that.
Not that I don't love talking to everybody from the comfort of my home, but
yeah.
You know, my commute in the morning can be about 2 seconds off if the dog meets me in the hallway and I don't get to my office in time. But otherwise, you know, the dog's mostly the only person I see every day, or
right.
every day, or the cat. So yeah, that was really helpful. One final question about the vaccine. Will you and your team be getting the vaccine?
As soon as it's available. Like, I mean, literally the microsecond after it's available, I will be there. So actually one member of my team, and he's put this on Twitter, so I'm sure he doesn't mind me sharing, Josh Knowles, is getting his vaccine this afternoon. And so, yeah, so he's on call. I'm unfortunately get a little vacation coming up, so I'm not on call till early in the next year. So I'll probably get mine in a few weeks, but Josh is getting his today. Our team will be first in line, and as soon as we can. And we want to support our patients. And if any of our patients have any concerns, we've encouraged them to make sure they call us and talk to us. And but my main message is to say that even although they came quickly, no corners were cut. Actually, no corners were cut. We just removed the space in between the steps, and then the new technology allowed us to move faster. And it's really what's going to keep us safe. At the end of the day, I often say this: that you can either catch the live virus that could kill you, or you can take the inactivated version that could save you. And at the end of the day, that's really what it comes down to.
Okay, so now I'm going to pivot off to a question about special populations. So HCM patients should get the vaccine. There's no contraindication at this time. nothing dangerous to that population. But do you think it will work long-term in an immunosuppressed patient, the transplant community? Or are we probably going to need some extra boosters?
Yeah, I mean, that's a really good and important question. And of course, for most vaccines, we are very careful with the immunosuppressed community. I mean, we certainly don't use any kind of live vaccine. I didn't mention, but some of the early vaccines, of course, are live. They're just a very small dose of the virus. So we, of course, don't use those in patients who are immunocompromised. It's likely we'll need special dosing. I think that's the answer there, because obviously, if you're taking drugs to suppress your immune system and you have a new entity, let's say just this protein that's been made that looks a bit foreign, you're not going to generate the same response if your immune system is suppressed. But that doesn't mean that you cannot be protected. And not only can you be protected, but of course it's particularly important that you're protected with an inactive version of the virus protein. So we'll be paying particular attention, of course, to the immunocompromised individuals.
Thank you on behalf of the transplant community for answering that unrelated question to the topic at hand. I think we've wrapped up our questions for today. We've taken quite enough of your time. I thank you so much for sharing your time and your work here. I'm really hoping people take some time and read. I have some more yet to finish. I didn't get to the end of the COVID time, so I didn't quite get there yet, but the stories are fascinating. The people you chose to feature, thank them all, for everybody who's reading this, for being willing to share their story. Lilani, for joining us today. And of course, your wonderful HCM team out at Stanford. Thank you so much for joining us.
Oh, thank you for having me. It was a real pleasure. Great to see you as always, Lisa.
You too.
Thank you for listening to Tales from the Heart. For more information on HCM, we encourage you to visit our website at 4hcm.org. Join us online for the conversation on our Facebook page or in our private group. Facebook page can be found at Hypertrophic Cardiomyopathy Association, and our Instagram handle is at 4HCM Warriors. That's the number 4 HCM Warriors. Follow us on Twitter at 4hcm.org. For those members of the LinkedIn community, you may want to follow the conversation on the Hypertrophic Cardiomyopathy Association group. Join us today. To contact the Hypertrophic Cardiomyopathy Association, you can call 973-983-7429. You can email us at support@4hcm.org or visit us online at our website, 4hcm.org, and send us an email from there. The Hypertrophic Cardiomyopathy Association is located in New Jersey and operates on East Coast time. We would like to thank our sponsors, MyoKardia, Invitae, Boston Scientific, and Cytokinetics, for their support of this program. Please remember to sign up for the HCM Strong Tour, Big Hearted Warriors Unite. Our virtual tour will begin September 3rd and include dates September 17th, October 8th, October 10th, October 24th, October 29th, November 12th, December 3rd, and December 10th. A few other events will be added. Check the updated registration information at 4hcm.org. Hope to see you at one of our upcoming meetings. The HCMA is partnering with MyoKardia, 23andMe, and others to help learn more about hypertrophic cardiomyopathy. Learn more about these initiatives at 4hcm.org. Invitae, a genetic testing company and a sponsor of Tales from the Heart, is proud to provide free genetic testing to families with hypertrophic cardiomyopathy. Please learn more at 4hcm.org. Hey, we know life with HCM can be challenging, and support is critical. That's why the HCMA has created an online support group system to help you and your loved ones live better with HCM. Join us. The HCMA is seeking volunteers on a number of different projects, including our online support group system, our peer-to-peer Big Hearted Friends system, and our legislative subcommittee. Please visit 4hcm.org to learn more today.